The subnetting is the interesting part. It is interesting because you can take one network and create multiple networks. That's really a wonderful advantage for network. As we know, it is only 32-bit for the whole world. Giving a separate network for each department is not possible. Instead of giving a separate network, we'll just take a network like this, for example, 10.0.0.0. We will create subnet out of it as many as we want. You see? But the mask will vary. The reason is, in this, the default mask is /8. Because only this bit are meant for network. Now we have given even the next octet, so the mask will become 16. So here the network is up to here. You can write like this /16, or you can also write like 255.255.0.0. 255.255 is 2 octet. You can write in any manner. But it is good to practice like this because this is easy, nothing to practice. It is easy so that when you configure on a router, Cisco router, only high-end devices will allow you to give like this on the router. Most of the router will ask you to type only like this, 255.255. Drawing a slash and giving a number /16/8/24/20/11, these are all called a CIDR notation. CIDR. CIDR. Why? C classless. This is class full, and now you make it classless. 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 A class. If I put a in front of anything, it becomes opposite in Greek. So I make it as a class or a classless. I make it as classless. So this notation is called as classless inter-domain notation. CIDR. Now, for subnetting, we are going to give more bits for networking than the default. That's the secret behind doing subnetting. That's the way that we do subnetting. We give more bits than the default. For 10, we usually give /8 because it is falling in class A. But subnetting is like breaking the class boundaries. So that we can get multiple subnets of the same network, so that they will all be an individual network. Advantage is you don't need to use the other networks. That same 10 network, but giving you different broadcast domains, different networks. So subnetting is a very good gift for networking. Alright, but this simple subnetting, what I have written here, is a very simple subnetting. Sometimes you may not be always expected to do simple. You need to do something great, difficult. So let us see some scenarios and then understand how to do subnetting, the difficult subnetting. But they are not going to be difficult because I'm going to break it as simple pieces, easy to swallow. Let us assume we have 7 departments in our new company. We started a new company and we have 7 different group of people doing 7 different roles, doing seven different job. One is taking care of the transportation, one is taking care of meeting the clients, one is taking care of planning the project, one is taking care of recruitment, hiring people. Likewise, I have 7 departments. For each department, I want to give a dedicated network so that each department will have their own broadcast domain, meaning they will all have their own groups. They won't mix with other groups. If each department has got a dedicated broadcast domain, what does that mean? The broadcast that is coming out of a computer in HR department will not impact the sales department. Will be only broadcasted within the HR department. We want grouping like that. We want to have groups, 7 groups, each independent of other. So 7 departments, we need 7 subnet. If you don't do subnetting, this is only one network, and as you said in the previous class, this is class A and the first IP is 10.0.0.1. The broadcast is 10.255.255.255 and the last one is 10.255.255.254. Exactly. So this is the first IP and then in the middle there are millions of address. This is the last IP and this is the address that is acting as a broadcast address for this particular network. So if any packet need to be sent to every single computer in this network, we will use that broadcast address. Any packet delivered to 10, 255, 255, 255 will go to every single computer in the 10 network. So we don't need to send packet for every single computer individually. You can use the broadcast address to send to everyone. Just one packet sent to this address, it will go to everyone. Okay. Now, when I do subnetting, for each subnet I will have first IP, last IP and broadcast IP. Remember, if you say a network should have a broadcast address and a range of IP address, first to last. Right now this is not a subnetted network, and this is the range and this is the broadcast. But when I do subnetting, it will vary because we are going to give some more bits from the host portion. Currently the host portion is this much. But when you do subnetting, you will be giving some bits to network, so the host portion will be decreased. So you won't get the same amount of IP, that will be reduced, but you will have more networks. And then for each subnet you will have a broadcast address. Now we are going to see quickly, before we get into the subnetting stuff, what are the advantages of doing subnetting? First reason, we do subnetting so that we will have a dedicated range of address for each department. We'll have a dedicated range of address for each department. Secondly, we will have an individual, a dedicated, a separate, unique broadcast address for each department. We will have a separate broadcast address. Thirdly, it will increase the efficiency of a network by reducing the unnecessary flooding of data. I repeat, subnetting will improve the efficiency of your network by reducing the unnecessary flooding of data. What do I mean by that? See, when you don't do subnetting, all 7 departments will be in one single big group. One single big group. The broadcast of a HR computer will impact everyone in the office, not only HR group. It will impact sales group, it will guest, it will impact the directors. It's going to unnecessarily disturb everyone in the office. Because it's a broadcast, it will go to everyone. When we do subnetting, the broadcast of HR group will be only inside the broadcast group of HR, the broadcast domain of HR, within the subnet of HR. It will not go to other departments. So we are avoiding flooding of the data to other departments. By doing so, we are not wasting their bandwidth and CPU. That improves the efficiency of your network. I want to repeat this again with a nice example. When all the computers of various departments are in same network, what will happen is, if this way, see, you need only a switch to connect them. And if a broadcast is sent from here, it will go to everyone. So this is a waste of bandwidth and CPU utilization for these members. Because there is no chance for this computer to look for a DHCP or ARP, whatever, that sends broadcast. If HR department is sending a broadcast, it is looking for something with the members of the same HR department, because it is layer 2 service. Broadcast. It is doing broadcasting. It's unnecessary for this broadcast to go to other department, waste their bandwidth and CPU. Because we have not done subnetting, because they are all in same network, this problem occurs. But when I do subnetting, the story changes. We cannot connect through a switch, rather we will have a router. And between these two, you will have a switch. For each department, you have a switch, and that switch will be connected to the router's different port. And each port in the router, we learned a separate broadcast domain. We learned that if I have 4 port router, I have 4 broadcast domain and 4 collision domain. So now, if a broadcast is sent from this PC, it will go up to here and this guy will stop. It won't allow it to go through the router to another port, another department. Broadcast is stopped. Router has got a broadcast domain. So these departments they don't unnecessarily suffer processing an unwanted packet. These links never get that broadcast. So the bandwidth of the links, the device CPUs are not wasted processing useless packets. So subnetting improves bandwidth, or subnetting improves the efficiency of the network by avoiding unnecessary flooding of data to all the departments. Fifthly, there is security. Because it is going through a router, because they are all in different network, they must go through a router. In the router, we will have access control list saying who can talk to whom. So you get more security now. See, these are all the benefits of subnetting. Any question?
No, sir. All good.
Okay. Let us now get into the scenario, back to the scenario, 7 department. So 7 departments. I need to take this one single network and make it as 7 networks. How? By giving some bits. This is already given for network, so don't disturb. 1, 2, 3, 4, 5, 6, 7, 8. Now these are the bits available for us. The host 24 bits. We want to give some bits for network. Should we give from here? No. You are giving for network. So you need to take close to the network. You can give from here. If you want more, you give more. More, more. You go from left to right. Give only the exact bit that is needed. So giving from left is what we have to do. Subnetting is giving from left. How many I should give? That's another problem. How many I should give? Should I give 7 bits for 7 departments? No. To calculate that, to find that, use the simple formula. 2 to the power of number of bits that you are going to give minus 1. This should give you 7. So what should be the 1? If I give 2 to the power of 3, means 3 bit if I give, that n is the number of bits I give, which is 8 minus 1, 7. Now I know how many bits I should give. How many? 7, huh?
7.
No, how many bits I should give for getting 7? 7 subnets? See, this is subnet.
3.
This n is the number of bits that we give. So for 7 departments, I want 7 subnets. For 7 subnets, I need to give just 3 bit. I can make this one single network as 7 subnets. If I give 3 bit for networking, I can make that one network as 7 networks. Okay, now 3 bits. How can this become 7? This is it. 1, 2, 3. If I have these 3 bits, all 3 can be 0. This is it. See, 1, 2, 3, 4, 5, 6 and 7, and all ones, when all the borrowed bits are 1, you should not use it. You should not use that one. So excluding that, how many are there? 7 different probabilities, 7 different combinations. Each combination can provide you a dedicated network. Alright, so now let's see how to do this. I'm going to take the first one, all zeros. So the first subnet is 10.0.0.0. But this time the mask is not 8. What is the new mask, I'll write like this, new subnet mask. The first
11.
octet 8 and the second octet 3. 3 means here it is 128 plus 64 plus 32. What is the value? 224. 00. Which can also be written as /11 as you said, but learn to write like this. I said why? Because all the routers, most of the routers will only accept this. Which one? You need to write like this. Okay, now this is the network. Without mask, you should not write, because without mask it means /8. The range will become different. Now let us go to the second network. Second network is 001, which means 1 is 32. 10.32.0.0/11. Next one. This is the second one. This is the third one, right? 010. Second one we have written already. Third one 010, which means 64 is on. 10.64.0.0/11. And what is next one? 011. Am I right?
0.
This one.
1, yeah, that's one.
011. What does that mean? 10.
0, 1, 1.
What 011? Add this.
10 to 120.
No.
120.
No. Add this too. 64 plus 32 is what? Why you say 120? 96.
Okay.
Is it not 96?
64 plus 32. Yes, 96.
Why we are adding that too?
Now just I'm looking at bit 128, 64.
Yeah, correct. But 128 is 0.
But yes, right. That value is on is only for the
This
64
too.
and
So
32 only.
only you need to add those values.
Okay.
Okay, you understood?
Yes, I got it, sir. I can tell you next one.
Mm-hmm.
Next one will be the 100, which means 120 10.128.0.0. Sorry,
Very nice.
128.0.0.
Correct. 128.0.0/11.
11. And next will be 128. Yes.
Okay, please.
So next will be 160. 160 dot
Correct.
0.0.11. Next will be 192. 0.0.11. And last one
We are not
we cannot
supposed
use
to
it.
use it, but I want you to write it.
Okay.
and put what
That will be
into mark like
yeah.
this. Okay.
Yes.
Now
Okay.
we have got 7 subnet for 7 departments. Let us see the range of IP address for this each department. There is a dedicated range, and here this is going to be 10.0.0.1, right?
Yes.
And then
First.
see the next network. Next network is 32, which means here it will go up to 31.
31. So 31 is a broadcast.
This is the last.
54 is okay.
Last IP, first IP, broadcast IP. This is the range and the broadcast for this first department.
Okay.
You should not assign these IP address to the other departments, only for first department. Now next department, 10.32.0.1 is the first IP. 10.63. 64 is the next
63.
network.
Yes. Yeah. 63.
255.255. And this is 10.63.255.254. Now what will be the first one? Tell me please.
10.96.0.1. Sorry, 64. 10.64.0.0.1. And last is a 10.95.255.255.
10.95.255.254.
And 10.95.255.254.
10.96.0.1, 10.128.0.1, 10.160.0.1, 10.192.0.1. And the reason why I ask you to write this is, without mistake you can write the broadcast of the last one, 10.223.255.255. How do you know this? Because you are referring to this one.
Okay.
If you don't have this, it will be difficult for you to write the broadcast. You understood? Okay.
Yes, sir. I got
Now
it.
copy this and fill the blanks in the middle, the gaps.
Okay.
Fill all the gaps. Now let me put it on the screen like this from here. From here you write in your own language. Next exercise you should do without any struggle. So understand and do this.
Okay, sir.
So let's take another example. 192.0.15.0. Let's say this is your network. This is class B, you know it. It is network, default network. 255, 255, 255, 0, which means already 24 byte is masked. These are already networks. 192.0.15, 1, 2, 3, 4, 5, 6, 7, 8. You got only these beats for both host and for giving some for the sake of subnetting. Yes, we have only these many bits. How many we are going to give and how many we are going to keep for host, that depends on the number of departments. Let's say this time we have only 5 departments. Two to the power of 2 minus 1 will give me 3 only. 2 to the power of 3 minus 1 gives me 7. So if I take only 2 bit, that won't be sufficient, correct?
Yes, sir. Right.
So I have to take 3 bits here.
See.
Even though I am going to get 7 department subnet, I am going to use only first 5. Maybe the other two I'll keep it for future use. Okay. Right now asked is only 5. So I'm just giving you an example that you get 3, after that you get only 7. So in between 3 and 7 you have 4, 5, 6. If you need 6 departments or 4 departments or 5 department, you have to take 3 bit only, no other option. You understood? No other option. 3 bit, and these are the 3 bits, and this 128, 64, 32. Same story like before. Now that same 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1. We don't use this. Now the first one, 192.0.15.0/27, which can also be written as new subnet mask 255, 255, 255, 224. You got it?
Okay.
3 bit 224. See, last time 3 bit we took from here, so we wrote 255 here, 224 here. This time you are taking from the last octet, so 224 will come where? The last octet.
The last octet.
Yeah?
Okay.
I'll write it nicely. 255, 255, 255. This is default mask, and now given 3 bits, which is 224. Clear? The new subnet mask, which is also
Yes, sir.
equal to what?
27 slash 27.
Okay. Now let us go to the second department. 001, which is 192.0.15.32 slash 27. Next,
192.0.15.64
exactly.
plus
Next,
27. 192.0.15.128/27.
no. How it is 128? You see, this
96,
is
sorry.
64. Now you are doing this one. 64 plus 32, isn't it? 64 plus 32, which is 96 slash 27. And
With combination.
and then you keep writing like this, 7, okay?
Yes.
But we need to find anyway. Now, what I want you to tell you here is very important. In class C, the first IP you see 192.0.15.1, but you see the broadcast. Broadcast will not be 255. The next network is 32. So the broadcast will be slash asset dot 31.
Yes, right.
So broadcast is not 255, 31. And the last is dot 30.
Last host ID.
So in each department, how many IP you get? 30 IP you get. First IP is 1, last IP is 30, which means you got 30 IPs in each department. You understood?
Yes, sir. So 30 IP in the sense 30 devices I can able to connect
in each department.
first department.
In each department. In this also you will get 30. You see, 192.0.15.33 is the first IP. See, it is not always the first IP should be dot 1. In class C, it will be like this. First IP is dot 33. The first computer in the second department gets 33 as the first IP. What is the broadcast?
192.0.15.14.
Yeah. Next network is
Sorry,
64.
64.
Right.
63 with me.
63.
Yes. 30.
Yeah?
Okay.
Right? Now, you copy this and then write for all 7
okay.
departments. I gave 5 departments. Now you write for 7 departments. It will be a practice.
Okay, sir.
I'll make it a 7. Okay, do now, please. The homework is 172 16 00 3 departments 10 00 4 departments, and then 192.168.1.0 3 departments. That's all. This 3.
Okay.
Finish it and bring it. If possible, after finishing, take a screenshot and then send it in the same chat window where you attend the class, right?
Okay.
Let me show you where to put.
Yes, I got it actually. The same. We are getting the meeting window, right?
Correct.
I noted down, sir. Yes.
All right. So see you tomorrow.
Okay, sir.